Hi everyone, I'm Praveen Raj, Assistant Professor in Mechanical Engineering Department, Jyoti Engineering College, Tirupati. Today I am going to discuss with you a topic in engineering mechanics which is called as the DAlemberts Principle. We all are familiar with the conditions of equilibrium in statics. That is sigma fx equal to 0, sigma fi equal to 0, sigma m equal to 0. So these conditions of equilibrium for statics mainly we use for solving the problems in free body diagrams as well as the structural mechanics. So similar to that, we can develop a condition of equilibrium in the dynamics also. So that is based on the Newton's second law. Okay, suppose if I am going to apply a force of magnitude F on a rigid body as shown in this figure. Okay, now from Newton's second law, we know that if I am applying a force on this rigid body in this particular direction, this body will move in the direction in which the force is applied. And from Newton's second law, we find the magnitude of that applied force as mass times its acceleration. Okay, so here A is the acceleration of the body which is moving towards the right side since I am applying that force towards the right side. Now, in order to keep that body in the equilibrium position, what I have to uh, do is that I have to apply a force of the same magnitude in the opposite direction. And we know that the magnitude of the applied force is mass times its acceleration. Now, in order to keep that body in the equilibrium position, I have to apply a force of magnitude ma in the opposite direction. Okay, that force which keeps that body, the force of magnitude ma, which keeps that body in the equilibrium position. That is called as the reverse effective force or inertia force. Reverse effective force or inertia force or a recursive force. Okay, so from Newton's second law, D'Alembert suggests that the equation sigma F equal to ma can be written in the form sigma F minus ma equal to 0. And from that equation, we know that the sigma F is the resultant of all the external forces acting on the body, and minus ma is the inertia force. And that inertia force, sometimes it is called as the D'Alembert's inertia force. Okay, so the purpose of that inertia force is to keep the body in the equilibrium position. And the negative sign indicates that the force is applied, that inertia force is applied in the opposite direction of the resultant force or the applied force or the external force. Okay, so based on this concept, there are the definition for D'Alembert's principle can be explained as follows. Okay, so according to the D'Alembert's principle, it states that the impressed force acting on the body are in dynamic equilibrium with the inertia force of the body under motion. So there are different definitions for this D'Alembert's principle. One definition is this one: the impressed force acting on the body are in dynamic equilibrium with the inertia force of the body under motion. Or we can say that the body is in dynamic equilibrium with the action of applied force as well as the inertia force. Or another definition, or in short, we can say that D'Alembert's principle is the resultant, the resultant of the external force sigma F and the inertia force. The magnitude of the inertia force is minus ma is always 0. Okay, so the resultant of the external force sigma F and the inertia force minus ma is always 0. And the equation sigma F minus ma equal to 0 is called as the condition of dynamic equilibrium. Okay, now uh, based on this concept of D'Alembert's principle, let us discuss a problem from the connected body system. Okay, now let us see that problem. Here, a system of frictionless pulleys carries two weights hang by an inextensible cord as shown in the figure. Make calculations for the tension in the cord and the acceleration of the weight. Proceed to work out the displacement and velocity of the weight W1 after 4 seconds from start. And presume that the system is released from rest. Okay. Now this is the figure given, and from the given figure, we understood that this block B of weight W1 equal to 50 Newton moves in the upward direction, and the weight W2 of magnitude 200 Newton, that is block A, will move in the downward direction. Okay, so the direction of motion for both block A and block B are understood from the figure. Okay, now by writing the kinetic equation of motion, we also understand that if A is the acceleration of block B, and yeah, that block B, we know that block B is moving in the upward direction. If it moves an acceleration of A in the upward direction, then the acceleration of block A will be A by 2, and that will be in the opposite direction of the motion of block B. So A by 2 is the acceleration of block A in the opposite direction of the movement of block B. So these things are understood from the kinetic equation or from the figure. Okay. Now let us draw the free body diagram of the system. Okay. Now from the figure, if you draw the free body diagram of block A and B. So let us see block B. So in block B, the forces acting are its weight 50 Newton acting in the downward direction, and the tensile force, we assume it as T1, which is equal to T. Okay, and since it moves in the upward direction, its acceleration is A marked in upward. Now on the other side, on the block A, we know that it moves with an acceleration of A by 2 in the downward direction, and its weight is 200 Newton. And also we know that the tension on the string which is connected to the second pulley and block A is T2, and we also know that the T2 is equal to 2 times T1 or 2 times T, and that is obtained from the free body diagram of the second pulley. And if we draw the free body diagram of the second pulley, T1 and T1, so T1 is the tension on the both sides of the pulley, and T2 is the tension acting on the downward direction. So from the figure, it is clear that T2 is equal to 2 times T1, which is equal to 2T. Now, writing the kinetic equations for the two blocks. Now, let us see the kinetic equation for block B. And since block B is moving in the upward direction, and we know that any force which is acting in the direction of motion is considered to be a positive force. So keeping that in mind, if we write the equation of motion, we know that the net force by F is equal to ma, mass times the acceleration. Now for the block B, let us see what is the next force. So net force is T1, or T1 is the force acting in the direction of motion, so it is considered to be a positive force. So T1 minus 50. So this weight is negative since it is acting in the opposite direction of the motion. So T1 minus 50 is equal to the mass is 50 by G, or 9.81 into A. Or from that, T is equal to 50 plus 50 by 9.81 into A, and mark it as equation number 1. Now applying the same condition on block A, we know that block A is moving in the downward direction. That means any force acting in the direction of motion is considered to be positive. So 200 Newton is considered to be a positive force. So 200 minus T2 is equal to 200 by 9.81 into the acceleration of the block A is A by 2. And we know that T2 is equal to 2 times T, or T is equal to 100 minus 50 by 9.81 into A, and that is equation number 2. Now equating 1 and 2, we will get the magnitude of the acceleration, which is equal to 4.905 meter per second square. Now that is the acceleration on the system. Now, for getting the tension value, substitute the value of acceleration of block A or B in expression 1 or 2, and the magnitude of the tension we obtained it as 75 Newton. Okay. Now, the second part of the question is you need to find out the uh, displacement and velocity of the first block when uh, it when it starts from rest at t is equal to 4 seconds. So you need to find out the displacement and velocity when t is equal to 4 seconds. And we know that from equation of motion, v is equal to u plus at, and since it starts from rest, its initial velocity is 0, so u is equal to 0. And acceleration of the first block, we have calculated it as 4.905. The velocity at t is equal to 4, you substitute t as 4. So the velocity after t is equal to 4 seconds is 9.62 meter per second. And similarly, the displacement of the second block S is equal to the equation ut plus half at square will yield the displacement after 4 seconds is equal to 39.24 meter. Okay. I hope that this portion is clear to everyone. We will meet with another topic in the next video. Thank you.